Alright, welcome back to part 2 of our Polygon test review. We're going to start with questions number 16 through 23. If you haven't checked out part 1 that has questions numbers 1 through 15, you can go ahead and do so. It doesn't matter if you do it before or after, but I do recommend checking that out. Alright, so questions 16 through 23 tell us to draw the following quadrilaterals and label congruent sides. They don't have to be perfect, but for the purposes of this video, I am going to use a ruler so that I can draw some semi-straight lines for you and get the best shapes I can. So number 16 says kite. So I've got a side there. So let's go ahead. And they're not going to be perfect, okay? Just going to try and get some semi-straight lines. Okay, and you don't have to make yours perfect. If you want to use a straight edge to do this, no one's going to stop you. Again, remember, in math, what makes a picture accurate is labels. And we are going to be labeling this picture, and I'm going to be taking care of this. And it connected all my sides for me, so that was nice of it. And it says to label the congruent sides. So this side and this side are congruent, and this side and this side are congruent. And that's my kite. So I'm going to go ahead and copy that over and paste it into my notes. Okay, the next quadrilateral it wants me to draw is a square. So I am going to do that for you. Again, it doesn't have to be perfect. Remember, what it has to be is roughly even, and it needs to be marked. So I will be erasing things to make it prettier. And I am conveniently using a ruler that is also a protractor, as you can see by the fact that I have degree markers on this ruler. So that is convenient. So my angles will all be perfectly 90 degrees and square angles. So that is a little bit cheater, I'll be honest with you. But don't forget that what makes pictures accurate is labels. So I do need to mark that these are square angles and that all 4 sides are congruent. Right, next shape is a rhombus. I'm going to just go ahead and freehand this one. Rhombus is like a square, only without having 90-degree angles. So again, all 4 sides are congruent. And we have a rectangle, which is just our 4 sides. Again, this thing is nice and easy for me. So then I need to mark my congruent sides. So let's go ahead and do that in just one moment. All right, so again, we want 4 right angles. It's kind of hard to draw here, but we'll do it. And then we're going to mark congruent sides. Okay. And the next one it wants us to draw is a parallelogram. So it doesn't have to be perfect. Of course, it's going to do that nicely for me. I'm going to go ahead and shrink that one down a little bit. That's what I've been doing without you seeing, to be honest. And remember, opposite sides are congruent and parallel. So I'm going to make these parallel. And these ones are parallel. And then I'm going to make these ones congruent. Let's go ahead and do that in a different color so it's a little easier to see. All right, so let's do that in blue. And then I'm going to move it over onto my answer sheet. And finally, the next one it wants me to draw is just any old trapezoid. Make it a little bit prettier. I don't like that one. that looks more parallelogram-y. But as long as I only mark one side parallel, then it's a trapezoid. Remember, in a trapezoid, nothing specific about the sides and their lengths. A regular trapezoid only has one pair of parallel sides, but if we have one pair of parallel sides and one right angle, that is what we call a right trapezoid. So when it says a right trapezoid, it wants a trapezoid that has one right angle. So this is a right trapezoid. Move that down here. I'm going to shrink it. One moment. And then finally, it wants us to draw an isosceles trapezoid. That's awful. Let me fix that. Draw a better one. Roughly straight lines. Yeah, that's a little bit better. And then we draw these two lines are parallel and these two lines are congruent. Because remember, isosceles for a trapezoid is the same thing as isosceles for a triangle. It means the two legs are congruent because isosceles means same legs, isosceles. All right, so now we're going to do number 24. And I'm sorry if you can hear, but the neighbor is mowing his lawn, but I can't control that. So I'm sorry if you can hear the lawn mowing being next door. I'm going to just go ahead and keep moving on. So we have number 24. It says ABCD is a parallelogram and is given that AB is 6, AD is 3, and angle D is 7D. So I'm going to go ahead and just draw another parallelogram over here. And a parallelogram. And I'm going to label it A, B, C, D. And it tells me that AB is 6, AD is 3, and angle D is 70. And then it wants me to find the other side lengths. So we know it says BC. We know that BC and AD are congruent. So BC is going to be 3. Let's go ahead and write that in. All right. And then we know that AB and DC are congruent because they're opposite sides. So DC is going to be 6. Now, it asked me to find angle A. Well, angle A is a consecutive angle to angle D. Consecutive angles in a parallelogram are supplementary. So the measure of angle A plus the measure of angle D are going to be equal to 180. So if measure of angle D is 70, then we can solve by subtracting 70. And we get that the measure of angle A is going to be 110 degrees. So measure of angle A is 110. And then angle B is going to be congruent to angle D because opposite angles are congruent. So opposite angle, so therefore it is also 70 degrees. All right, moving right along, it tells me that we are going to solve for X and A in parallelogram X, Y, or W, X, Y, Z. And we're assuming it's a parallelogram, mostly because it looks like a parallelogram. It's in the quadrilateral section. Normally I wouldn't have you assume anything, but it's next to other parallelograms, and we're just going to assume in this case because it didn't give me any other information to deter me from that. So we're going to solve for X first, and it says given angle Y and angle Z. So it gives me angle Y, which is here, and angle Z, which is here. And we can see those are consecutive angles, so they're going to add to 180. So we know that the measure of angle Y plus the measure of angle Z is going to be equal to 180. That's 0. All right, so we're going to fill in what we have. So it tells me that the measure of angle Y is 2x minus 3, and the measure of angle Z is x plus 9, and that all equals 180. And now we're going to combine like terms. So my like terms are x and 2x, so 2x plus x is 3x, and then negative 3 plus 9 is positive 6, and that equals 180. And we're going to subtract 6 from both sides, and we get 3x equals 174. Divide both sides by 3, and then we're going to go ahead and get 174 divided by 3, and we get 58. So x equals 58. And as usual, you do need to show all of your work in order to receive credit, so make sure you do that. Now let's go ahead and solve for A. Let's see what information they give us to solve for A with. Okay, now it tells me that given that side length xw, which is this side length here, is side length xw is 5a plus 4, and yz is 7a minus 20, and those are going to be congruent to each other, so we're going to just set them equal. So 5a plus 4 equals 7a minus 20, and we're going to go ahead and solve for a. I'm going to go ahead and subtract 5a from both sides, because I don't like negative variables. You can do minus 7a if you want, but again, I personally prefer to not divide by negative numbers. You may do it if you wish. I won't stop you, as long as it's an accurate way to do it. All right, I'm going to add 20 to both sides. So I get 24 equals 2a. Divide by 2. And a is equal to 12. I know what 12 equals a, because that'll keep it in the same order. You guys get to see that I pulled up the ruler on accident. So 12. All right, now moving on to number 26. It says following figure is a rectangle, so that's some important information. So let's highlight it. It's a rectangle, and it wants us to solve for the missing variables, the x, y, w, z, a, and b. Now, w, x, y, and z are going to be equal, or easy, sorry. And that's because they're all for the angles, and we know that every angle is 90 degrees. So that's what we're going to use for every single one of these. So W is easy enough. That's just 90. So that's the easy one. Let's go ahead and make that a little neater. All right, now let's solve for x. So we get 5x equals 90. Divide both sides by 5. X equals 90 divided by 5. It's going to be 18. So x equals 18. All right, for y, we get 3y equals 90. Divide both sides by 3. Y equals 30. 30. And then z, we get 2z equals 90. Divide by 2. And z equals 45. Easy enough. Okay, so that's the easy part. All right, so the other thing we know about rectangles is that opposite sides are congruent. Okay, so we know that this side and this side are congruent, and this side and this side are congruent. So A and B are actually not that difficult to solve for either. We're just going to set each side equal to each other. So 12a minus 23 is equal to 5a minus 2. Subtract 5a from both sides, and we get 7a minus 23 equals negative 2. Add 23. We get 7a equals 21. Divide by 7. A equals 3. Okay. And for B, it's going to be 4b equals 8. Divide by 4. And B equals 2. Not too difficult there. All right, for number 17, it wants me to find the area and perimeter for the isosceles trapezoid. So we know that this side is congruent to this side, and that makes it isosceles. So we can go ahead and do the perimeter. That's going to be simple enough. So that's just going to be, for this one, it's going to be perimeter is equal to 13 plus 13 plus 16 plus 6. So it's 13 plus 13 plus 16 plus 6. And that's going to be 48. So the perimeter is 48. We're not given units, so we don't have to give units. And then we need to find out what the height is in order to find the area. So to figure out what the height is, we're going to have to go ahead and do some logic here, because we don't have a base in order to use Pythagorean theorem, but we can figure it out. So this base here is 16, and this base here is 6. So we can tell that the difference is going to be 10. So if it's an isosceles, we can tell that this here, so now this is 6 and this is 6. So I take 6 away from the larger base, I have 10. I need to split it evenly between the two sides that I would have. So let me sketch this line again. I have it right here. So if this portion that I'm going to highlight right here, that's 6, then logically this right here and this right here have to add up to 10. Well, I have 2 of them, so they should each be 5. So now I have a right triangle with a hypotenuse of 13 and a short leg of 5 and an unknown long leg. So we're just going to use our a squared plus b squared equals c squared. And so I have 5 squared plus my unknown squared equals 13 squared. 25 plus b squared equals 169. Subtract 25. B squared equals 144. Take the square root, and b equals 12. So our height is 12. So now that we have that information, we have enough information to solve for the area of this isosceles trapezoid. So let's go ahead and do that. Area of a trapezoid is base 1 plus base 2 over 2 times height. If I have base 1 as 16 and base 2 as 6 and height as 12, that's going to be 16 plus 6 over 2 times 12. And I can just type it just like this into my calculator. So control divide to get my fraction. 16 plus 6 over 2 times 12. I get 132. So the area is 132. Okay, so that's not too bad. Now we're going to find area and perimeter of each of the following figures for numbers 28 through 31. Perimeter of 28, we're going to have 11 plus 10 plus 8. 11 plus 10 is 21, plus 8 is 29. So the area is 29 miles. It gives you units, you give me units. Again, area is 1/2 base times height. Base is 8, height is 9.6. So area is 1/2 times 8 times 9.6. We're just going to run that through the calculator. So control divide, 1/2 times 8 times 9.6. I get 38.4. So that's going to be 38.4 miles squared. All right, number 29. Easy enough. Again, perimeter. Just add up all the numbers around it. We get 12 plus 9 plus 9. And addition is commutative, so I can add them in any order I want. 9 plus 9 is 18. 12 plus 18. Well, 2 plus 8 is 10. So this is going to equal 30. Okay, because that would be 10 plus 10 plus 10. So the area here is 30, and it is still miles. Some big triangles. And again, the formula for area is 1/2 base times height. Since the red one here is the height, the base is the one that it's perpendicular to, okay? The base is the side the height is perpendicular to. Even if the base is outside of the triangle, the base is the side length that the height is perpendicular to because it's altitude, right? That's the one you're going to look for. All right, so area base is 12, height is 6.7. I don't really like multiplying decimals either, that's why we're using the calculator. So you get 1/2 times 12 times 6.7. So control divide, 1/2 times 12 times 6.7. I get 40.2 miles squared. And remember, area is square units, Perimeter is just units. All right, moving on to number 30. Number 30 is a rectangle. Now, rectangles, remember, have two opposite sides are congruent. So we know that this side is 10.3, and we know that this side is 7.1. You can write those sides in so that it's easier for you, but you can also remember that the perimeter of a rectangle is 2 times the length plus 2 times the width. So you can either write it as 10.3 plus 10.3 plus 7.1 plus 7.1, or you can write perimeter equals 2 times 10.3 plus 2 times 7.1. On formula charts, you will see it written this way, but so long as you can remember that each side has to be added twice, you'll be okay. So let's just go ahead and do that. So we're going to have 2, let's go ahead and put parentheses, 2 times 10.3, close parentheses, plus 2, open parentheses, 2 times 7.1. Before I hit enter, I'm going to double check, make sure those are my numbers. 10.3, 7.1. Okay, hit enter. I get, oops, I had a typo. Let's try that again. I said 110. And I'm going to go ahead and stick my parentheses back in there for safety purposes. I don't like risking no parentheses. It's okay. All right, 34.8. That makes way more sense. So our perimeter is 34.8. And again, we're in miles. All right. And now we're going to do the area. Area of a rectangle or any other parallelogram, you can use base times height. Rectangles, we also can use length times width. So area equals base times height. Or you can use for a rectangle length times width. So we can say that the base or length is equal to 10.3 and height or width is equal to 7.1. It doesn't matter which formula you're using. Make sure you're consistent, but also write down your givens before you do the multiplication. So area is equal to 10.3 times 7.1. So let's do that math. 10.3 times 7.1, and we get 73.13. Okay, we get 73.13 miles squared. All right, last one for this video. Then we'll take a break. Delete, delete. All right, the last one is a square. We can tell it's a square because it has side lengths that are congruent next to each other, like that, 9.3 and 9.3. It's always good to notice. So we have for perimeter 9.3 plus 9.3 plus 9.3 plus 9.3, or because it's a square and adding the same thing over and over again is repeated addition is multiplication. So the formula for the perimeter of a square is 4 times the side length. In this case, our side length is 9.3, so the perimeter is 4 times 9.3. So let's run that to the calculator quickly. So 9.3 times 4, we get 37.2. And now we're in inches. All right. And then we're going to do area. And the area for a square, the formula is side squared. side again is 9.3. So the area here is going to be 9.3 squared. So 9.3 squared. And we get 86.49. So 86.49 inches squared. And that is numbers 16 through 31. We will finish up with the rest of them in part 3 of this video. Make sure you check back on the Google Classroom for updates. I will go ahead and make an announcement as soon as that is ready. If you want to keep an eye out for that, that would be a good idea. Remember, the review is worth 10 extra credit points on your test, so I do recommend making sure you get this done. If you have any questions, just shoot me an email or comment on the Google Classroom, and I will get back to you almost as soon as I possibly can before Monday. I'll be in the classroom Monday morning. If you have any questions before the test, that's a good time to do it. I'll see you then. Bye.